Hi, welcome to the Differential Equations Primer for CISO linear systems, single input, single output linear systems. I'm Dr. Rico Picconi. I'm a professor at St. Martin's University, and I'm in the Department of Mechanical Engineering. This is actually intended not so much as a course in differential equations or even a replacement for a course in differential equations, or even something to do before differential equations courses. It is in fact something that I envision people using to refresh themselves on differential equations before they enter their upper division engineering courses. So specifically at St. Martin's, we have courses in mechatronics, for instance, in the first term of the junior year, of the third year in the engineering program, and I teach that course. And I noticed that there were a lot of folks coming in who took differential equations because it's a prerequisite for the course, but who were not necessarily fully prepared to start using their differential equations knowledge in that course. So I expect that students hit the ground running in differential equations, and I always sort of gave advice about how to go back and brush up on differential equations, but fortunately the Helen Inga Marcus School of Engineering that houses the Mechanical Engineering Department at St. Martin's supported me to create this series of lectures and the primer text as well that I'm going to show you now. So how this is going to work is I'll give these lectures. There are actually 5 lectures with content. The rest, or this one, is just an introduction, of course. But for all of the lectures, so each of the 5 lectures, I would like you to go to this website and print out a PDF before the lecture begins, before you watch the lecture, so you can take notes on top of it. So if you go here, you get to my website and to the Differential Equations Primer. So the primer has this little page here that has the entire PDF as one big file, so you can go there, or you can get them as individual lecture files. So if we go to the entire thing, the Differential Equations Primer for CISO linear systems, you can see the table of contents. Just to sketch this out roughly, we will start by, in the next lecture, introducing CISO linear systems. And in the following lecture, we will discuss how a unique solution exists. And then in the remaining 3 lectures, we're going to sketch out and work out the solution procedure for these CISO linear systems. So first finding a homogeneous solution, or also known as a complementary solution, then finding the particular solution using the method of undetermined coefficients, and then finally finding the general solution by summing those, and the specific solution by applying initial conditions. So it's really just one procedure for solving differential equations here, but I'm going to go through it just sort of in one track here. So there aren't any alternative solution methods presented at all. They exist, but I assume you learned those in your differential equations course, and if you needed to, you could go brush up on those for something else. But in the classes that I teach, I highly recommend using this method, which is not so you could use Laplace transforms, for instance, as another method, but I'm not going to present that here. So there will be exercises at the end of each of these sections, each of these lectures that I'll give. Each of the lectures, once we start actually solving problems, there will be problems, and there are also answers at the end. So it's a nice little text. I think it's like 25 pages or something. So not too bad. And we're just going to work straight through it in the course. So there will be sections, there will be parts like this that will have blank spots in them, where I will be writing in Illustrator here on top of the lecture, and you will be filling this in on yours as well. That's why I want you to go and print these before, so that you have them, have a pen, so when you're watching the lecture you can take notes. But a lot of the material will be there. You don't have to write everything down. You can just write in sort of the fill-ins. And then when we work example problems like we do in this lecture, that will be blank, and I will be working those out sort of on the board. So you can take notes in there as well. So, okay, I think that is all I wanted to introduce. So let's just get started.